Want to nail engineering manager interviews at FAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into FAANG. You could be next. To learn more, register for our free webinar.
Do you want to let me know a little bit about what you're hoping to get out of this mock interview?
This is actually my first mock interview ever. I haven't really done any of these, so I guess if you could be and I don't mean this sarcastically, as nitpicky as you can. I just want to get better.
I think that makes perfect sense. Let me go over some just logistics before we get started. Welcome to Interview Kickstart. So these are going to be 1 hour mock interviews. Basically we will spend we'll do 1 or 2 coding questions depending on how far we get, difficulty, etc., things like that. That'll be the main chunk for 45 minutes, and I'll leave about 5 to 10 minutes at the end for feedback. We can do 5 minutes of intro in the beginning. Yeah, I mean, why don't you tell me a little bit about what you're currently doing and what kind of roles or companies that you're looking to apply for?
I'm doing kind of automation work. I'm writing out a application in Python to automate applications, Docker applications to manage pipeline. So there is development, there's a bit of DevOps, but what I'm looking to do is I'm kind of gonna do a big wide search for jobs. I got about a year in the industry, so I don't have that much experience, but I know enough to get past the entry hurdle. You could say I'm a junior, get into these entry level positions and whatnot. I know Git, I know Python, Java, JavaScript. I'm going to be using Python for this, and I guess I'm pretty much just looking for, I don't really for me, it's not FAANG or bust. It's more I want to get into a job where I feel comfortable, I'm getting paid a decent amount, and I'm just kind of set for life, basically.
Well, yeah, I think it's good that you're looking for software engineer, coding type positions. That'll definitely be something that you'll hopefully be able to find. So yeah, I can definitely help you with that. Like you mentioned, you want the feedback to be pretty critique. So just to clarify, it's going to be some backend position. I'm guessing that's really, like you mentioned, around junior or entry level. So you're kind of looking for.
Yep, pretty much.
Awesome. Yeah, I think that gives me some really good context. All right. Yep. Looks like Python, right? Is that correct?
Yep. Is this Python 2 or Python 3?
No, this is Python 2. If you want Python 3, there's a Python 3 section.
Okay, there you go.
Yeah, this one's Python 3. Okay. All right. Let me grab my notes really quickly. Basically gonna kind of give you a prompt, give you an example. I'll kind of go over it with you, and then basically I'll give the rest, and then the rest of the time will be up to you. It's been a while since I've done Python, but I think these are comment blocks. Perfect. Okay, so for today, just a reminder, so this is the trees one. Yes, yeah, okay. Today we're gonna assume that this intelligence officer, that intercepted a message over the wire. There are some engineers that are been able to reconstruct, a data structure here. In this case, a binary tree, where each node represents a character. It was able to basically take the message that was sent over the wire and kind of create a binary tree out of it. Someone said that if you basically read the binary tree, left to right, you would be able to decrypt the message. So the purpose of this whole exercise is for you to write an algorithm that basically decrypts the message. And if you look here, an example, reading to left to right, you get privy, and that's why the output is privy. Does that make sense?
Yep, that makes sense.
All right. Yeah, and the rest of the time is up for you.
All right. So it looks like, from what I'm seeing right now, it looks like a root or a leaf to root path. left side, which could be, that could be, let's say that's an in order. It's more like it's not exactly a pre either. It's, let's say we have, if we were to go down this tree, and we were to do it post order, it'd go down the I, R, and then it would start with the P. Sorry, in order, in order, my bad. And then it would go to the R, but then it would go to the V, which is not what we want.
Mm-hmm.
So we start with the root, we're going to continue down to go to the left. Continue down and go to the left. But when we hit the null node and we go back up here, we know that the leftmost value, the min value, is where we begin. When we return that back up, then when we hit this node, we need to somehow save this V, but not take the rightmost node. Okay, I see. So it's the left subtree, this value. Let's make this even smaller. So say it's like, hey, would this be correct?
TEA for the second tree, yes, that would be the subject, assuming it's going to be like, you know, left and right branch.
Okay. Let me do just a traversal at the beginning here. So we're going to have this is the main function. I'm just going to call it a DFS for now. And we're going to throw in the root of the tree. And then we're going to say if not root. So if the root is, if the tree is invalid, or if we're at a leaf node. Actually, let's do a bigger function before this. We'll make this a helper function. We'll call this D root. Row image. This is going to be a helper function. Drop this down. It's not the tree. So when I get an invalid tree, what would you like me to return?
Let's assume actually that the message itself will be there won't be like an invalid tree. And can you be more descriptive for like an invalid tree? What you mean by
Like,
that?
oh, I'm just thinking like an edge case. Like say I get a function that messes up. Do you want me to like raise an error? You want me to return -1? Like yeah, they just return.
Let's assume that the tree will always be well formed, so there won't be any like weird cases where the tree, you know, is not constructed properly. So you'll be
Gotcha.
given the root of the node, and you'll build and you'll be guaranteed that this root will, or this tree will will not throw any errors essentially as you traverse
Gotcha.
through.
Okay, and then if not root, we will return just return up the tree for now. I'm not looking at returning anything after the leaf node. I just want to make sure I return back up for the DFS. Call it down here. This is going to be the result. Since I don't want to be forming a bunch of strings, I'm going to be adding this probably as I go through my traversal of the tree. I'm going to be adding it to this array, and then I'm going to join the array at the end to make a string. So you want this as a string, right?
Yeah, it's gonna be the output's gonna be a string. That's correct.
Okay, so we have that, and if we were to do, let's just say a normal traversal here, where if that we're going to the null nodes and then we go back up, and if we wanted to go like in order, you would add it right here and go IRP. It's no more. Another thing I was thinking about is maybe even having another data structure to store the rightmost value. Let's just go through and see if we can get the leftmost. So we're going to keep going down until we hit the root, then we go back up. Go down, that's going to send it to R and Y. And we'll go down to P, B. Well, no, R will stay here. You see, is it in the valve? Like, is it this for the character?
Yeah, yeah, you can assume. I mean, either or. You can assume vowel should work, and they'll be like you mentioned, left or right. So this should be fine.
Okay, so if we append this, return. Right now, I know I'm not using these variables. These are just placeholders for now. So if we append this for now, the output is going to be P. Wait, no, this is post order. It's PV RYI. Okay. Let's do an even bigger one. Instead of doing all these tabs, let's do can't even think of a word. Alphabet. Okay.
Hey, sorry, can you be more specific when you mean alphabet?
Oh, like the word is, that's like the keyword. Like instead of privy, it's the keyword would be alphabet.
Keyword alphabet.
I can choose
sorry.
it.
Oh yeah, for the input. Yeah, I see what you mean.
I couldn't think of a long word. I'm sorry. I was grasping at straws there. Okay. So it has to be a binary tree that we know. Okay.
Yeah, but to kind of let you know though, like there's not actually no restriction to the order of like the things. Like this privy could have been written in several different ways, if that makes sense, right? Like the Y could be under the V or under the P. Or sorry, I guess you could rearrange the tree. Maybe the Y might not be under, like, or the I and Y could like maybe be moved under the V, and technically it would still output the same thing, right? I can give you like an example. So if we did, it was like R, then like key was still here, and then I's here, we have V here, and then Y here. Like it still would output privy, if that makes sense. Like the tree can be kind of arranged. But it's from right to left, it still reads the same.
Oh, okay.
If that makes sense.
That does make sense. Okay. So I think, okay, so if not root, return res. So if we keep going down the left side and we append after we hit the bottom. So now we'll get the P, and then we hit go into the right side, it returns up. Then the root returns up. Then we go down to the right. And then the right goes down, it sees there's no left. So the left pops up, right then appends it. Right then goes again, checks to see if there's a left one. Okay, I think, is this it? Pen, return. Is this return gonna, no? Well, let's run this through again. So we have the P, or we're throwing in the root. Root goes through, or R is the current node. And then we call the DFS recursive function on it. And then P is thrown to the top of the stack, and then we go through P. P goes through, and then it calls this again, we're at a null node, so it goes back up, and then P then appends to the root.val. So now P is in here. And then we go back up to the right. So we append the right, there's nothing there, it pops back up. We're going back to the root now. The root is now appended. So now R is in here. And then we go to the right side of the root. I is put in. I checks to see if the left is there. Nothing's there, pops back out, appends I. Then it goes down to the right. Checks, sees V. V does the same thing, then Y. Okay, I think we can give this a test run.
Yeah, I'm kind of curious in general. So are we expecting this to actually return privy in this case, or is it going to return something different? 'Cause I think actually if you look above, like what you have like under the output pre-order, like lines 15 through 18, I think you've kind of already kind of went through like what would be the actual kind of like output for the different traversals would be, right?
Yeah,
In this case, what kind of traversal do you have here?
this is an in order. I think.
Yes. Yeah, this is an in order.
So for the first one, it wouldn't work, but for this case, it would, right?
Yeah, for the in order one, it would work for the second example right here. I would agree with that, but
Okay.
yeah, of course, like for the first one, it seems like that's not working.
I see. What I could also do is I could think of it as in paths. That's what I was trying to do with the alphabet. So if we only go like up this leftmost path, and then we only go up this rightmost path, or the next leftmost path, and the next one, and the next one. That's the traversal I need to make, basically. So in order to do that, I may be thinking about a level order traversal rather than DFS. Because if I go level order, and I go through, I pop this most, reverse it, and I pop this most, reverse it. That could work. But I would need to do multiple runs through it to do it that way. PRIV.
Can you let me know what you mean, clarify what you mean by multiple runs?
So I'm thinking about like if I were to do like the BFS right here, I can actually just put it in here for now. I'd have my queue. We're gonna save this DFS for later. I'll have my queue and we just call it that. And then we'll have we'll throw in the root of it. And then while queue, so while we still have stuff in the queue, we'll do node equals q.pop left. So this is going to be the first node, and then we want to check for the levels. It'll be like equals length of q for just do range of nodes. So this is like in case we have like a bunch of letters here. And then what we want is we're already popping left here. we get this node. So it would be I, and then once we get the next set, it would be R, but the Y would also be in there, and then it would be, we don't like, we pop the Y in the next one. But we can change that here, I feel like. We with the, can maybe make our temp array. So this is where I think the change should be, is right here. So the normal BFS traversal, we add everything at once. But if we add all the rightmost nodes in the level order, this example would, we have the Y and then we have the V. We can flip them around. In this example, we have the I, V, Y, but if we flip that around, it's not correct. The level doesn't really matter. It's about how further, how many times it goes to the right, but the height of it almost. The level does matter. It's the furthest level. Add this, we'll go I, V, Y. Think of like a way to, maybe we could store a tuple, store the height as well, but this also tracks the height when we go through these Q nodes. And we'd still have to go through this twice because I'd need to go through the right side nodes. Unless I do it all in one go right here. You want to go at the depth of it. I don't think the BFS will work. Just because like I see the clear path here from root to, leaf to root. And I just need to continue doing that path through some type of traversal. And I don't think the level order traversal would work compared to this, just because when I think leaf to root, I'm thinking DFS traversal through it.
Right. So I think that, yeah, I think that actually I think the traversal part here is important, but it's not as important as I think. Maybe there's some other information that also needs to be tracked. I think the point where the word levels is something that's actually, I think, hinting towards the right direction of things. Like, can you think about how you could kind of like take this tree and kind of create levels out of it? Like, how would you go about, I guess, like, creating levels out of these trees?
Well, what I could do is to normally store levels, like in a tree here, to get the furthest most level, when I hit this, I would return 0, and then you go through this, you return well, you need like a 0. You go through, and like when you hit the root, you hit 0, and then as it comes up, you turn. So this will be like, say, the furthest to most nodes. So it'd be this plus 1. Plus 1. Actually, no, we'll just return the plus 1. So plus 1. So we have 0. We go all the way down to the root, which root returns 0. And then at the end, we'd return this would give us, well, we need to actually differentiate between these two. Get like the maximum height. So
So actually, oh yeah, go ahead.
the max level is where we want to start the left, on the left.
Yep. Or the maximum is start left. So here when we're saying levels, there's actually, I think the way that you're viewing it is it seems like line by line kind of level, right? Like down the line.
Well, I mean like depth of it. Like this is
Yeah,
two levels.
that's probably like you mentioned depth. So I think that would work if we were to say like, you know, if the characters reveal from maybe like a different way, but I'm curious like if we want to maybe kind of like change that concept of like that level, if we like rotate it or think of it a different way, that would be better. Like I'm curious like for the horizontal levels, like how's that gonna, what's your plan for producing the right solution?
What was the question again for the
Or
horizontal?
yeah, for like the levels, I'm curious, like using like it seems like you're doing depth. Like how do you think you can kind of get to solution using this kind of depth out, this like level by level depth algorithm?
I would do. I was going to go to the very bottom of this, and then I'd recurse my way up. Like once I hit the leaf node, it'd recurse up the left side of the tree. And then once it would do that, then I would have to find a way to get back to the lowest most level and then recurse that back up and do the same thing for this one.
Got it. So if there were like other letters like right here, let's just say like something like yeah, something like this, like how would you handle it in that case?
I think the cutoff is when something no longer has a left node, right? That's when we need to like think about it. Because if this had no longer, we go down the left side of the tree, right? And then once we hit nothing on the left side of the tree, we're like, okay, then the previous most node needs to be added. And then once that's added, if we have something on the right, we know that once we hit the root, that rightmost node is the next go.
I mean, in this situation, what do you think the output of this tree would produce?
Be PRIVAVY.
PRB is actually, I would say that's almost there to the right solution, but not the actual solution. I think would be a little different actually. Remember, this is right. This is left to right. So if you were to read this left to right, like what letters would you hit first?
Oh, you'd see the B first.
Yeah, We hit
And
the B before the rest of the like the stuff on the IAVY, yeah. So
then,
left to right. So if we think about this like left to right, actually the P is still first. I think do we agree with that, Ashley? We would still hit the P first. So if we drew out these lines, right, a little more clearly, I think we would see that actually. Oops, sorry. I think we can see that the P actually still is the first letter that shows up.
mhm.
Does that make sense or?
Yeah. So now I'm thinking about it like left to right, and it looks like the R and the B are the exact same leftmost key in this instance. So how would I determine like what goes first? Hmm.
Sure, just to confirm, like the output that I would be expecting is P R B I A V Y. So
Okay.
P, and then the next leftmost would be, or so you start with P because that's the leftmost. And remember, the leftmost is like like if you took like some ruler basically and kind of slided it across this tree. So you hit P, then you would hit RB at the same time. But you know, since R is higher, you would read R then B, then I and A, then V, then Y. Y is like the quote rightmost. So it is a little confusing because it uses the concept left and right, and you know there's left and right childs, but this is like more thinking of like uh like it's not related to those like children and that kind of concept. If that makes sense.
Yeah. Okay. And now I see what you mean by like think about inverting it.
Yeah, so
Yeah.
yeah, let's think about that. So if we inverted it, like how would you kind of like assign those levels then?
Well, this would be the root, and then this would be the next level, right? The R and the B would be in the next level, then I and A, then V and Y, right?
Mhm.
Okay. So how would I go through the inversion of this? So if we start at the root and say we invert this one, we go down the left side, lay on the left side, and then we say this is the new start of it. And then instead of thinking going up, we're going to the right of it and then down. So we go to the min value, and the min value becomes our root. And then we kind of, how do we go? Well, we need to store the predecessors, right? No, it doesn't seem right. You got me stumped. I'm not sure how I would invert this.
Yeah, no worries. Like so, in sort of the so we so if we think of things like you mentioned vertically, and let's not think about too much about the traversals, but more about like the data. So what data do you think we would need to kind of track? There seems like there needs to be like data that there's two pieces of data I would identify as like being really important to track at each node. Like what would you think about if you had to like track like two pieces of data? I think you kind of already kind of have it in your code.
The level of it,
Okay, yeah.
and then if it has a left node.
I think the level is right. And then probably what I would say is like, you know, the actual letter value of the node, right?
Yep.
So we all know that P is associated with this sort of level. And that level should be represent somehow some sort of like order where we know that's the leftmost, that's the first one, right? And of course, like the next level would be like the R and B, then the I and A, then the V, then the Y, right? So for example, we split this up by levels, it's actually going to look something like this actually, right? Like we know that this is like if we split it by levels, it looks something more like this, right? Versus if we did like, the horizontal levels that you propose, it would probably look something like this, right? A little different.
Yep.
So if we're gonna think about like the vertical type way, like how can we kind of represent so we make sure that we maintain this sort of kind of ordering we have right here?
Well, we have to maybe go to like the min value of each subtree.
The mean value of each subtree. So I think we if we had some sort of like, remember we're I think the level in the parameter would work, right? I think we just need potentially like data structure to help us kind of like capture it properly.
So we've got a hash table.
Yeah, I think that would or uh yeah, I think something like that would definitely work. Yes.
Tracking the level. This would be, well, for the lowest level would be this.
Yeah, I think that's going towards the right direction. Going towards the right direction, but I think there's like some logic that needs to be consistent. Remember, we want to maintain some sort of like proper order so that we know that P is going to be first one that we encounter in the hash table, the RB and then the IA and then the V and the Y. I think in this case, what we're going to see is that we're going to get horizontal levels because you're going to associate R with the first one, and then P and I will be the next one, B, et cetera, right?
Yeah.
Like it looks like currently as is, you're assigning the levels currently kind of like this still, right? And I don't know if that's gonna produce like the right ordering, if that makes sense.
Yeah.
We want to we kind of like what you said, invert it so that the zero is kind of like here, right? Something like this, I guess, right?
Oh, I think I see. We want, okay.
Yeah.
So the root, think about this as the root. Left will go, well, we're just gonna, for now, just do negatives, horizontal level. And right will go awesome. So then we have the ordering, right? Oh, wait, I took away the.
Yeah, so this is definitely going more towards the right idea for sure. Um, yeah, I would argue this is much closer than what we had at the beginning, but I think unfortunately we are like out of time. I do want to keep it under like around 45 minutes or so, just because in a real interview, it usually doesn't go past 45 minutes. Um,
Yeah, that's
for
fine. That's
so
fine.
I do want to make sure that we actually take the rest of the time to actually going to go over feedback if that works for you.
Yeah, that's good. That works for me.
Yeah, and I do encourage you to take some extra time to kind of like solve this on your own. Like I said, I think you're making really good progress, and you're getting closer to a solution basically. But yeah, I basically kind of listed a bunch of like strengths and gaps that I kind of noticed throughout the interview. I'll go over the gaps first, and then go over the strengths after. But I think I would have spent more time to think of like a proper algorithm before coding. I think it's good to just try to like think of, not worry about the code, but actually understand like as a person, how would I kind of solve this sort of problem, regardless of using any sort of code, so that it produces the right solution. Up front, I would have mentioned the structure of the tree or of the node. I think you already pointed out like, oh, is this going to be val? I think just like saying up front, like, hey, I'm going to use val, left, right, and things like that. Just up front, I think would be better.
Gotcha.
Since we had some confusion on the input that relates to output, like actually producing this tree to like this tree will produce this output, et cetera, et cetera. It seemed like there's a little bit of confusion around that. Um, the
Uh,
original code. Oh,
what did you mean by that again?
so like I think what we had like I think when we originally had this privy, right? Like you were kind of going through these different examples, but you're kind of reconstructing the tree. You were kind of going backwards essentially. You're doing or you're saying that like this is you're going backwards where like, oh, you're saying T and then they would make this tree. I think essentially you would want to do is make the tree, then say like, okay, what is out of this tree? What message does it make, right?
Oh, I see. I see.
Yeah, so it was a little bit backwards, I think, in terms of like how it was kind of approached. Right, because this tree is the input and then like output is the privy. So you want to start with the tree first and then say, hey, this is the word that will come out of this tree. The original code that you had or solution that you had was in in order for traversal, which we knew, based off this stuff that you had earlier in like line 17, it wouldn't produce the right output. So I would just take a closer look on like, hey, is this solution I'm making aligning with all the other stuff I'm pointing out with, right?
Mhm.
I think there's a bit of hinting that definitely needed. I think especially the leveling kind of took a while for you to kind of like move away from the horizontal leveling and kind of think of like a little bit bigger picture. So definitely try to keep your mind a little bit open on like, okay, like we know the traversals won't work. We know that this horizontal stuff won't work. Like what other possible ways can I go about like solving this problem, right? And now going. I mean, do you have any questions about those gaps that I mentioned?
No, that makes sense. It's think before coding, like specify like maybe tell the interviewer if you need to use a node class, what the values are, like val, left, right. Keep your mind open. If you get stuck, like start brainstorming. Don't just start writing code like
Yeah.
and go
Yeah,
quiet.
yeah, there's still a lot of like you mentioned. I think those are all great things that you summarize back. So in terms of the strength, those I think are strengths. You did a good job at thinking of edge case at the beginning. I think it's good to clarify those out. You were able to kind of take yourself outside of, okay, I know pre-order, in order, post order won't work, so let's think of some other way, like level order, traversal, and things like that. So I think that's the right approach that you're gonna have there. Good communication throughout the interview, like the actual talking back and forth, you explaining your process. I think all that was fine. That's actually how you kind of want to do it. And the code was clean and readable. Like I didn't have issues reading it or understanding it. So that's like good on that front. Just those gaps that I mentioned before. I think if you work on those, you'll definitely be solid. Uh, we do have a couple minutes left. I was wondering if you have any last minute questions before you end for today.
Um, I guess like in terms of like this type of thing, I feel like when it comes to like this, I know how to invert it like upside down, but I've never done it left to right, like an
Yeah,
inversion left to
yeah,
right.
that's yeah, that's definitely like I actually give this problem to entry level and mid level engineers quite a bit. It is interesting to see like the different solutions that people produce from it. So uh
I
yeah,
really like it. It's a good question.
yeah, it
Yeah.
has a nice story around it, right? And it's a
Yeah.
very different classic problem that like usually a lot of tree problems are, oh, just do in order and you get your solution, right? But in this
Mhm.
case, it's like that's only like a small part of the problem. There's actually a different aspect to the problem, and that's why I kind of really like this kind of problem because it's like a mini two-part.
Yeah, because it's like you get so used to just like going to the tree, least common ancestor, most common ancestor, what's next, what's left. But it's like you never really think about it. Well, what if you flip it on its side? And like, I guess this
Yep.
is not really a question. It's just like I really like this question. It's a really good
Yep.
one.
Yeah, and like I was mentioned, like definitely take some time afterwards to think about it, how you would solve it, things like that. It's it'll definitely like kind of give you a cool perspective. Yeah. If there's no other questions, we can end a little bit early, and I think we do have another interview tomorrow for a graph. So looking forward to that one as well.
Yep. See you then.